Okay, before you continue listening, make sure you get out your record sheet that we started with today when we were doing the menu items. And inside of that foldable are definitions. I've written them on the slides coming up, and then all you need to do is write a couple of examples for each one to make sure you're clear on each thing. So we're going to talk about variables. We're going to talk about what it means to evaluate, what a term is, what like terms are, and what it means to distribute. Variables, we use that term a lot in algebra, but variables are letters that are replacing a description. So for example, today we talked about bacon, and instead of saying, which stood for 2 slices of bacon, and we use the variable b squared to stand for that. And you might, for example, if you're talking about a fenced yard and you wanted to talk about how long the fence is, you could say L stands for the length of fence in feet or whatever, and that would be the distance around the thing. But instead of writing the words, the length of fence in feet, you could anytime you want to do that, you'd use the letter L. Another way we use variables in algebra is when we, for example, we know the output and we're trying to find the input, and we're solving for an unknown quantity, which we can do by subtracting 8 on both sides. And we're going to get 2 equals negative 2x. Divide by negative 2, and we're going to get x equals negative 1. So we didn't know what it was, but now we know what the quantity is that makes both sides true. The third way we use variables in algebra is to talk about description, but it's used to help understand a pattern, and we've been doing that with our tile pattern. So here, the shape number 1, shape number 2, shape number 3, shape number 4 is the n, and then the n squared. So the output, in this case, the f of x, is going to be n squared, the shape number times the shape number. So the n, the variable, stands for the shape number. Sometimes to evaluate means, it always means how much is it worth, but sometimes you might be substituting what you know about the number for the variable and then doing some calculations. So let's say I was buying 10 gallons of gas. 10 gallons of gas, it would be $3.50. Substituting in for the G times 10, so it would be $35. Evaluating, finding the value. This case by substituting. Sometimes evaluating just means calculating. So in this case, you have a string of an expression that you need to calculate. So you're going to go ahead and start with the parentheses and do what's inside the parentheses. And you end up with 5 minus 2 squared, negative 3 plus 1 is negative 2. Then you have to do the exponents, which is right here. So then you get 5 minus 4 times negative 2. And then you got to do the multiplication in order. And there's the 5 minus, that's not multiplication or division. Some of you learned the order of operations wrong, and you got to remember that it's just multiplication or division in order. So now it's 5 minus negative 8, or 5 plus 8, because 5 minus negative 8 is the same thing as 5 plus 8, and then you end up with 13. So sometimes evaluating is just finding out how much it's worth. Terms are, we count the number of terms by counting the things that are separated by addition or subtraction. So if we had x squared plus 2x plus 5, we would have 3 terms. Right here, 1, 2, and 3. But if we had x squared plus 2x minus 2x plus 5, we'll be able to put like terms together. These would go together. 2x minus 2x is 0x. We'd have x squared plus 5. We'd have a total of 2 terms. If we counted this 1, 2, 3, 4, originally there's 4 there. The 1, 2, 3, 4. But once we combine them, we go ahead and get 2. So we'll talk more about like terms in the next. when we simplify, we're looking to find things to make it just easier to understand. And if we have a huge string of things like x squared plus 5x minus 2 plus 7 minus 6x plus 3x squared, it's not very simple. So what we're going to do is we're going to look at the like terms. We're going to look at things that have the same exponent and the same power. So x squared and 3x squared, remember there's a 1 right there. We just didn't write it. We can put those together. So we have a total of 4 x squares. And then we can look for some other like terms. We have the 5x and the negative 6x, which is negative 1x. And then the last thing are the constants. And 7 and negative 2 is plus 5. So now we have 4x squared minus 1x plus 5. They cannot be combined because the x and the x squared do not have the same power. So now we have 3 terms, simplified by combining like terms. Same variable, same power, which means they have the same exponent. And the distribution is one of the last ways we talk about simplifying. And distribution means that out here there's a number, and it says we have negative 3 of all of these things. So we're going to go ahead and multiply negative 3 by all the terms inside. So that means we multiply negative 3 times x, and here's where it gets complicated with all those negatives. So I'm going to call this plus negative 3 times negative 2, because I'm going to think of this minus 2 as adding a negative 2. Much easier for me than all that subtraction. So then we get a negative 3x. Negative 3 times negative 2 is positive 6. Negative 3x plus 6. So distribution means all the terms outside the parentheses. Negative 3 is the only term outside the parentheses right now, right here. It's going to be multiplied by everything inside. So here's our negative 3 by x and our negative 3 by negative 2. All multiplied by all the terms inside the parentheses. So this is our simplified answer right there. Whoops, that got messy. Sum it up. To sum it up, let's talk about all the vocabulary that we've hit on here. First off, we have variables here. And those variables, in this case, are probably being used to describe a pattern. When we ask to simplify a string of these variables and numbers, this is called an expression, the whole thing, because there's no equal sign. There's nothing to solve. We're just simplifying or making it, finding out how much this is worth if we plug in a number for it. We have like terms here. Right now there's 1, 2, 3, 4, 5 terms, but we're going to go ahead and simplify by putting the like terms together. And let's see, we look for the ones that have the same variable. This has an x and a squared. This has an x and a squared. So they can go together. And that makes 4x squared. And then we have these two that go together because they have the same variable in x. Now it says minus 2x. I'm going to think of that as adding a negative 2x. It's easier for me. Subtracting a positive 4x is the same thing as adding a negative 4x. And when I put these together, then I have 6 x's, but they're both negative. That's easier for me to think of. If you wrote it as minus 6x, it would be exactly the same. And then the last thing we have is this 2 that's just hanging out on its own. After simplifying now, we have 1, 2, 3 terms, because there are no like terms you can add together. And if we wanted to evaluate this, and then let's say we want to value for something easy like 1, we would substitute 1 in for x. So we get 4 times 1 squared plus negative 6 times 1 plus 2. And so then we would do the exponent first. Then we get 1 squared is 1. 4 times 1. Negative 6 times 1 plus 2. 4 plus negative 6 plus 2. That works out to be 0. So evaluating means to find out how much it's worth. Terms are the number of things separated by addition or subtraction. Like terms have the same variable and the same exponent. Same variable, same exponent. Oop, not that one, this one. And then the last thing we talked about what's distribution? And distribution is when you have to multiply everything on the outside of a parentheses by everything inside. So in this case, the negative 3 is going to be multiplied by the opposite of x. And then the negative 3 is going to be multiplied by 5. Right now we have two terms. Negative 3 times the opposite of x is positive 3x. And negative 3 times 5 is negative 15. Two terms. Can't simplify anymore because these don't have the same exponent or variable.